right? And it's, so it's a 1/2 inch, bracket's a 1/2 inch thick, and this is 5/8. That's the sizes there, right? So it's a 1/2 inch thick, it's 5/8, right? And the 5 inch thick base plate is much larger than the bracket, right? So it goes on for a long ways. The weld leg length is 3/8 inch, and all the components are A36. The loaded hole is 1.25 inch in diameter, made it bigger this time, and located 1.5 inch in both directions from the lower corner. So 1.5 inch from both corners, right? Okay. Okay, find the stresses at the hole, the highest stresses in the bracket, and the factor of safety for yielding. Okay. Hey, it's an easy thing, right? What is it? Chunk of steel, we welded it to the wall. We want to know if it's going to break. Can I get any easier? You don't have to answer that. I keep asking the same question. I don't get any answers, do I? Okay, so, well, I gotta model this darn thing, right? Okay, so, let's see if I can't model this darn thing and get at least something that's close here. So, what do? SolidWorks, new one, new part.
Can you work that as an assembly?
I would not do it as an assembly. I would do it as a part. Assemblies and the simulation don't necessarily get along all that well. We play with a little bit of them later. But okay, let's do probably on the front plane here. I'm gonna start sketching. I'm gonna do a little bit of sketching, right? And so it doesn't really matter, but I'm gonna draw some lines, right? So what am I gonna do? I'm gonna go out over here. And then I'm gonna, actually, I think I'll even chicken out on this. Let me just draw a rectangle, because that would be the sort of easy thing to do, right? Okay, right, and then I think I'm gonna cut the corner off it by doing a fillet weld. A fillet, excuse me. And I think I'm gonna make that really big. Like that. Use the corners. Okay. Maybe a little bigger, right? How about 3 inches? Why not? Kind of looks like a picture. Okay. Then we get some dimensions on this. Mine, of course, going to be different than yours because that's the kind of guy I am. So let's make this 3.5. Right. And actually, let's. I'm gonna have to. I'll make it better. Make it 4.5. 4.5. Okay, and then I'll make this one like 4.5. Come on. Okay, and then I'm going to put a hole out here. It's somewhere out over here. Okay, and I'm going to say 0. What? 0.5625. Okay. And I'll put some dimensions on that. Between the center and here. And I'll make that about 1.25. And then I'm going to put dimensions from the center to there. Oh, come on. Okay, smart dimension. I want a smart dimension from the center to there. And I'll make that 1.25 as well. Get a hole out there somewhere. Okay. And I'm going to say I'm going to exit the sketch. That kind of looks right. Not real happy with it, but it kind of looks right. I'll make a feature out of it. We'll extrude it. And I'm going to make it both directions. Well, it doesn't really matter. One direction is fine. 0.6, just because So we got chunk of stuff. Does that kind of look like a chunk of stuff? Something sort of like it.
The radius of that bracket, does it matter?
I don't know.
It's-
They didn't specify.
Yep.
So we get to find out, I guess. Right? Okay, so I have a chunk of stuff. Now, was that hard modeling?
That's solid model.
Solid modeling, okay. So now we need to make the bracket. Okay, and so we'll whip this thing around here. I'll click on the black plane here, and I'm gonna do the sketch. Right, on that plane. I'll even get around to where I'm in that plane, right? And I think what I'll do is I'm gonna make a great big rectangle here. Like what? Yeah, like that. Okay. Looks like I got a great big rectangle there on the back of it. I'm gonna say I like that. I'm gonna get out of the sketch. And then we'll make a feature out of that. And then I'm gonna extrude it. And I'm gonna extrude it that way there, looks pretty good. And 0.6, yeah, that's fine, okay. So, looks like I got chunk of stuff. Does it look something like the drawing? Oh, except for the welds, good point. We'll deal with those later, right, okay. I'll put them there. Okay, so now what are we gonna do? Well, actually, let's do the welds now, okay? There is a weld thing in SolidWorks, but it's kind of a pain in the neck to use. So it's usually easier just to do a fillet. And so we can actually, in here, there are, where are they at now? Fillets. Okay, so what kind of fillet do I wanna make? Well, I'm gonna make I don't really wanna make a radius one, I wanna make a
Edge.
square one, yes. And where's the variable fillet size, face fillet? I think that's a face fillet.
Do the drop down.
Is it, oh, that's right, you're right, I need to do the chamfer instead of the fillet, right? There we go, we gotta do a chamfer, there we go. Thank you there. And so what am I gonna chamfer? I'm gonna chamfer you there, and you there, right? And I'm gonna chamfer them, and I'm gonna do what, well, it's giving me some number like that, that's my length. That's the length across the surface, right? It's actually not the leg length, but you guys can do some geometry. There's actually different ways you can specify them if you wanna do them the other way. We can do them the other way, there's specification types up there. Let's do partial preview, what's it gonna look like? How about full preview, what's it look like? Hey, that looks kinda like the model, doesn't it? So we're gonna go, that's okay. So shoot. How am I doing now?
Pretty good.
Wasn't that easier than, you can play with the weld stuff, but that's easier, right? Okay. So, okay. Now, think we have a solid model? Happy with the solid model? Not too unhappy with the solid model? So let's go to the simulation here. We'll do a new study, static. We can name this if we want to, but alright, just to say we did so. And then what do we need to do? We need some material. So we're gonna apply material. And it's A36, which I thought I actually had A36, right? You guys think I just make these things up? Of course I make them up. Okay, and then we're gonna put some loads on it. Well, let's see, we're gonna fixture this. And so, okay, how am I going to fix this? So before we do anything, let's go sort of how am I going to fix this? Well, in the problem statement, it's what? What is the problem statement? Because they tend to be, it says that the 5/8, the 5/8 thick base plate, which is much larger than the bracket. So it says this base plate is much larger. Much larger. What does that mean when I say it's much larger? It means where the base plate is going to be constrained is long ways away from where the sky is. And that's an intentional statement that says that we want to get the boundary conditions far enough away to where their location does not affect, stresses in the boundary condition do not affect the stresses around here. So this thing wants to move as much as possible, right? If it was closer, what would happen? If you had things that were welded on closer, right? Because I mean, it's not gonna just be a plate, it's gonna be other kinds of stuff, right? What that tends to do is that tends to stiffen the thing up more, right? Tends to make that plate stronger, right? Which may or may not help things actually, by the way, but usually does. When we stiffen them up, it usually makes the stresses less because there are other things carrying the loads. They don't deform as much, right? So typically what we do in this kind of condition is I want to let this thing bend. So if I see stresses that are going from here out to the edge where there's a boundary condition and they haven't gotten uniform, right? And that means that I need to expound my boundaries further away to where things get uniform over there, right? So that I can get farther away from the areas of interest. And this we do an awful lot, right? We do this an awful lot where we say, we just want to look at this and I don't want the boundary conditions to mess with me, so what am I going to do? I'm going to make the boundary conditions a long way away, right? So I don't care. They're not the thing that's messing with me, right? Other things are messing with me. So in this particular case, now, that means I have to fix the boundary conditions, and usually what I want to do is I want to fix edges. Because the last thing I want to do is fix the back face. If I fix the back face of this, what's it going to do? Well, it's going to make that thing look like it's a completely rigid plate, and that 5/8 plate won't deform, right? That's wrong. That 5/8 plate will deform. Right, that back plate will deform as we see that load on it, and we need to let it do that. Right, so how are we going to fix it? Well, typically we'll go fix it on the edges, and we'll try to fix it as little as possible. So I kind of keep the edges in the plane and let the thing itself deform. So my usual approach on this is I go around and fix the outer edges to make sure that they're in the plane. Let them rotate, but fix them so they're in that vertical plane. And then you got to go fix a couple of them so it doesn't go accelerating off into space, right? Because that's not a good thing to do, right? So we'll kind of make it like it's a simply supported beam in some ways, right? But and so that's what my typical approach to these kinds of things is to do. So I'm going to have to go put some boundary conditions on there that kind of represent that. So I'm going to get on the back here, and I'm going to wind up fixing a lot of these edges. Right, so let's go. Of course, we're going to do fixture, advanced fixtures, and we're going to do reference geometry. And what I'm going to do is, the first thing I'm going to do is I'm going to fix all these edges, all 4 of them here. Come on. And then as a reference plane, I'm going to pick this back one, and I'm going to fix the things that are normal to that reference plane. Right, so what am I doing? I fix them all. So all of those edges are going to stay in that plane, right? Now the rest of the plate can move, right? But the edges itself are going to stay in the plane. That's the sort of infinite plane approach, right? I get far enough away, the thing gets infinite, right? You might think if the plate goes on to infinity. Eventually, right, when we push on it, it's not going to care, right? It's going to be flat. If it goes on to infinity, and that's kind of an infinity assumption. Now, of course, that's not enough, because right now what it's going to want to do is it'll certainly hold in that plane, but that load that when we put it on there is going to accelerate it in a direction that's not going to be happy, right? Because it's got nothing resisting it from sliding along the plane, right? So we have to put some things in that resist it sliding along the plane. And it doesn't really matter. You can put them up here at the top, you can put them at the bottom. It's not, you probably shouldn't do both, because then it's not going to allow it to, one of them to move. Now, though both is not necessarily the worst assumption you can make on that, I guess. I would, if you assume it's an infinite plane, both is really sort of does that. But let's fix the top one here now, just because I'm at the top, not because there's any other reason. And this particular one, I'm gonna use this vertical surface, this top surface as the reference plane, and again, I'm gonna fix it out of plane. So what that's gonna do, that's gonna hold it, right? That's gonna hold all the loads. So what happens, all the load's gonna get through here and flow up to that location over there, right? So we're gonna go, okay. And if you wanted to, you could probably fix this bottom one the same way, and it probably wouldn't hurt anything. I'm gonna do the same on the edges over here, because I know that if I don't, right, it's gonna go sideways, even though there's no load in the sideways direction. You better fix at least one of them, because you gotta constrain the thing in space. Right, so now we fixed it all three directions. I've got three fixtures here. If we expand the fixture tree out, I've got all three of them right. I've got the back plane constrained. I've got the top so it can't go down, can't go that way, and I've got this edge so it can't go that way, so that those two fixed it in space, right? It's not gonna be able to move anywhere. I think it's fixed in space, can't go anywhere, which means at least the model geometry is valid. Now, we may not be happy with those constraints. We may change them later, in fact, probably will, but hey, at least gets us started, right? Don't let perfection get in the way of at least taking a shot at something. Okay, make some sense there? A little bit? Right, so now all we gotta do is put a load on it, right? And so what do? We put a load, right, and we went back. Looks like we got a force, gonna put a force on the hole over there. We don't really want it normal to the hole, we want it selected direction. Well, I'll pick this plane over there, and I want it normal to that direction, right? And let's see, normal to that direction. I want it going the other way, and I'm gonna put, say, 5,000 pounds, just for giggles. Okay. So I got 5,000 pounds going down there. My numbers are different than yours because that's what I do. Okay, so now I can mesh this guy up, alright, create the mesh. We're gonna run the density down because we don't really care all that much. We just wanna see if it works at all. I have a mesh, looks like a mesh there. I can push run. And first of all, it looks like it
Deformed.
deformed. And it's doing a pretty good job, and the stresses are pretty uniform by the time I get out here in the edges, right? I mean, there's no big stresses out over here around the edges, right? They're all pretty much, you can there's a little bit up here because that's where the main force is getting reacted out, but it goes to that blue neutral in here, pretty uniform all the way around. I think it's pretty, I think my boundary conditions are far enough away to not give us trouble, right? They're certainly not giving us big problems, and if I was worried about it, I could make the rectangle a little bit bigger and it'd push things further out and see if it actually changes anything. But it doesn't look like it's really changing things, right? I'm getting stresses up here and I'm getting stresses down over there, right, okay? Now, do we believe this?
Yes.
No. Why don't we believe this?
It's a computer.
It's a computer. It's another Microsoft help answer. Technically correct, right? So I'll have to
It's
get
on.
it's on, right? So we don't believe anything it says, right? So there's skepticism. Okay, do I believe it over here?
Yes.
Well, I don't know. Doesn't have very good mesh density, right? I probably got one node in here. It's telling me that. So we ought to refine it a little bit, right? How about, do I believe it over by this hole? the UWB response.
Well, you look, yeah, you can see there's more stress on the sides and then less.
Yeah, I got a little bit sides and stress
Yeah,
over
it's
here,
pretty, you know.
but, do I believe it over there? Well, how did I load it? I put a force on that hole. What's the force gonna do on that hole?
Elongate it.
Well, it's gonna push on the surface. If you put a force on a surface, it's gonna apply the force to the surface, and it's gonna apply the force to the surface equally. Right, it's in a particular direction, but it's applying the force to the surface equally all the way around that surface. The problem is that can we actually load it like that? No, right? Because that's gonna put a compressive force. My loading it around here is gonna put a compressive force on the bottom, but on the top, it's gonna put a tensile force. Because it's all going that way, right? So it gets a compressive force on the bottom, basically shear forces on the side and a tensile force at the top. Well, can I load it like that? No, because how am I gonna load it? I'm gonna put a pin in there.